Hey there, thanks for watching PT Bubbles. This video is going to be mainly about cooling with extra fans, an extra transmission cooler, and looking at the cylinder head because of some overheating issues. But we're going to look at a number of other things too. First, we're going to look at the cold air intake, upgrade it to a K&N Apollo filter, and utilize the scoops that I put on the hood of the PT to get cold air more directly into the turbocharger inlet. We're gonna add on a TurboXS manual boost increase little valve. We will upgrade the radiator fan to a Flex-A-Lite Black Magic fan, which has about 3,300 CFM, so about 1,000 CFM, cubic feet per minute of air more than the stock fan. We will upgrade the transmission cooler and 2 additional cooling fans. They're 11-inch American Volt fans. They push about 2,500 CFM each. We're going to do a timing belt reinstallation because I discovered that the exhaust cam was 1 tooth retarded, so had to remove the belt and reinstall that, and I'm going to go into a lot of detail on that so you get to see the exact belt installation and what I find now currently to be the easiest way to get it installed, including looping it over the cam gears and getting it onto the tensioner pulley. A bit of an addendum and an update to previous processes I've put online. And lastly, I'm going to remove the cylinder head where I discover there are bent valves due to potentially valve guides not properly prepped for the larger intake valves that were installed. And I'll discuss a couple of additional upgrades other than the valves that I'm adding on to the cylinder head this time around, including the rocker arms and the lifters. And we'll discuss how those will help with performance, lubrication, and vacuum. All right, enjoy. I've always wanted to be able to get actual cold air from the outside into the throttle body on the PT Cruiser. And I've tried running on a naturally aspirated through, there's a little opening. If you look at the bumper down by the fog light, there's another opening that's just to allow cold air to kind of blow in. And I've routed a hose onto that up alongside the radiator, I think I did on the naturally aspirated, up into the K&N filter. This is the Apollo, okay, filter. That was supposed to be good for this. That was okay. The hose was basically crap on it, and it tore up, and it just ended up being a waste of time. But for the turbocharged, since I already put the 2 little scoops on the hood and drilled the hole so that they're actually functional, these guys right here, from the turbocharger inlet, this is the stock hose that goes to that. And what I did was I cut off the section that goes to the stock cold air intake box. That's this right here. Okay, I cut it off, and I'm gonna grind it down a little more so that I can fit this hose onto it a little better and then clamp it. And as you can see, that goes into the K&N filter, and I've spent a long time making sure that this will fit in that space where the cold air intake goes. And again, I'm using the K&N Apollo filter, and I want to use this one instead of the, you can get a K&N filter for the turbocharged PT with already the metal pipe that fits, and the K&N filter has a little blockade, a little wall setup that you can put in, but it just points that filter kind of right down to where the stock cold air intake is supposed to get cold air from the wheel well, the driver's side wheel well. I want something better with actual cold air, so that's why I'm doing this. So the K&N Apollo filter is enclosed. Okay, so the filter's inside there, but this enclosure, this is different from the K&N filter for the turbocharged that you can just purchase because it's open, right? It's just sucking in air from the engine compartment. This enclosure will let me funnel the air in through the scoops on the hood, or one of them. I'll have to run a hose down, a flexible hose, which will then feed into the Apollo. And that, I had to get this crazy thing. It's 4 inches by 3.5, I think. The 4 inches is so that it will fit over the Apollo. It's going to be snug, but okay. So, and it's going to be shaped kind of like this, because you got from the turbocharger, or it's actually to the turbocharger inlet coming out of the K&N Apollo. This will have another hose, and I'm going to have to shorten it and whatnot so that it fits vertically, horizontally, hose up to the scoop in the hood. And then it already has, because it's the K&N filter, it's got the right hose to go to the crankcase breather port. So that is how I'm going to finally, I think, if this works, and I'll show you, accomplish actual cold air coming in through the scoop on the hood, through the cold air intake filter, in this case the K&N Apollo, into the turbocharger inlet. So actual cold air, more pressure on it. Hopefully it'll make a difference. All right, let's talk a little bit about what I'm doing. I have the TurboXS, it's like a manual turbo booster. The TurboXS BC HP BC. I got this from Modern Performance. Here's the sheet I'm using to install. But you attach it to the wastegate between the line that goes straight to the wastegate from the turbo booster. You put it in between, and it allows you to manually, with a coarse and a fine adjuster, change the level of boost that you get to see how it does. I mean, it's really easy to put on. Just a matter of getting your hands in here. Okay, got that on the wastegate. Just gotta zip tie it so it won't come off. So here we're starting the Flex-A-Lite variable speed control module, as well as the 40 amp large fuse box that comes with it. We're starting that install. And in this instance, because I have removed the stock cold air intake and I'm using the K&N system in a different cold air intake setup, I have a lot more room right there between the battery and the power distribution center to do some of these installs. And though the wiring is certainly looking like it's getting packed, which it is, there's now enough room to have some relays, the variable speed fan control, and possibly some other things. I was able to secure the variable speed fan control and the fuse for it to the mounting bracket for the power distribution center, which also doubles as the bracket for the cold air intake. So I was able to use that space that opened up to mount those things right there on the power distribution center. Being mounted right there next to the power distribution center is handy because that gives you very close access to the battery, the positive posts and the negative posts. On the battery itself, several grounding locations that are right there along the fender wall on the inside of the engine compartment, and then also the power distribution center itself, you know, including all of the connections, relays that you may want to tap into for things like switched ignition power, or maybe the direct power to the radiator fan, or you have the several posts that you can bolt down connections to that you want to have direct positive battery feed to. So that's an advantage being right there next to the power distribution center. So I was able to connect the positive terminal directly to that post in the power distribution center. So what you're going to see here, what follows, is a lot of me just wiring in this whole system. So a lot of soldering, adding wiring looms, making all the connections to the variable speed controller, and then eventually the three-way switch that I install on the interior, and the new radiator fan itself. If you're only interested in installing the variable speed controller with a temp sender, just telling it when to turn it on and off automatically, you can do that. The switch is not required, so if you're not doing that, you can leave that whole section out. But I definitely wanted that manual control, and I have found that to be beneficial at times. I like being able to turn that fan on to 100% when I feel like it needs cooling. Being the car being boosted with the additional boost I've added, as well as some of the other modifications to the motor, like the oversized pistons, the upgraded camshafts, changes to the head. It's definitely getting warm, so I do want that control. So you may want to as well if you've modified your motor. The air conditioning connection and the fan activation has been tricky to understand and figure out. Once it's all said and done, it's not really that complicated. Getting there was a bit of a chore. And thank you very much to Martin Built, another YouTube channel where he does a lot of work on Jeeps and Durangos, Dakotas, because he does a Flex-A-Lite fan install very similar to what I'm doing. And I absolutely used his video as a reference for a lot of things, and in particular, the air conditioning fan activation. Before filming this and doing this work on the PT, I had already done the Flex-A-Lite installation on my Durango. With that setup, the motor had a viscous clutch fan. That's one where it's bolted, just a metal fan directly to the front of the motor, and it spins with a belt almost at all times. But what that meant is the activation of the air conditioning fan. There's two fans on the Durango. The activation is different. The way that I wired that and that I assumed I might be able to do on the PT was different. What you see here will be temporary until I discover the need to do several more things additional to get it to work on the PT. You do need the high-speed radiator fan relay installed, and then you can use one of the pins on there, either the negative pin 87 or the positive, the negative pin 85 or the positive 87, to then run to the variable speed fan controller to activate the aftermarket fan. In my case, it's the Blackmagic Extreme Flex-A-Lite fan. What I ended up doing was using pin 87 with the high-speed radiator fan installed and connecting to pin 8 on the variable speed fan controller, because that's for the positive activation. Pin 7 on the VSC, the variable speed controller, I'll just call it the VSC like it does. Pin 7 is if you use a negative trigger, which is what I did on the Durango with the relay completely removed. On the PT, relay is installed, and I use the positive trigger, which is actually the power. Once that relay is activated by the PCM, it then sends the PCM sends a negative, trips the negative pin 85. What that does is closes the circuit in the relay, which allows the positive signal power to be sent to the fan. So I used the positive pin 87, went to pin 8 on the variable speed controller. Then it started working. Turn on the AC, the fan comes on high speed like it should with air conditioning. Same with the defrost. If you turn on defrost, your fan will kick on. So that worked. There was one other thing I had to do. There needs to be a resistor. I'm going to talk about this again when it comes to that fan installation. Stock fans in the PT have a resistor built-in mounted on the fan. I can't recall if that's the case on naturally aspirated PTs, but definitely on the turbo PTs, there's a resistor on the fan itself. And this resistor, it's like 100 watt, 10 amp resistor, I believe, goes between the both positive wires for the low speed and the high speed fan. Normally the wiring stock has 3 wires that go to the radiator fan: your ground, and then the positive wire for the low speed fan, which comes from the low speed relay, and then the wire for the high speed fan from the high speed relay. In stock, there's a resistor between the 2 positive lines, and it's mounted on the fan itself. So without that resistor there, which of course the Blackmagic Extreme or probably any aftermarket fan won't have, it won't activate. The fan won't turn on, air conditioning doesn't even turn on. So had to get an aftermarket fan, and this is again credit to Martin Built, because he did this on his Jeep when he installed the Flex-A-Lite system. He got that resistor, as I did, and as you'll see, the Blackmagic fan is wired in directly to the variable speed fan controller. Okay, that's all good and fine. But what I did is I used the stock fan connector, which was still, you know, from the stock wiring, still down there by where the stock fan goes. So I used that connector from the fan side, which has the relay, and I installed an aftermarket relay to do this, and just bolted it, you know, bolted it to the radiator mount there, and as well as the ground wire to it. So I've actually plugged into the stock radiator fan wiring using the wiring off of the stock fan, radiator fan assembly. Like, I removed all that. You could remove the stock resistor if you're going to do this as well, because it's all there. The one that I grabbed happened to, the resistor broke during removal, so I had to use an aftermarket one, and I wired that in. But you don't have to do that if you just take all of the wiring off of the stock fan, and then just plug that in, just so that the PCM sees that resistor and thinks the fan is therefore plugged in, I guess is the purpose. By doing that, everything works as it should. So a quick update on a few things I did not capture on video. Working on the interior of the PT to get the switch installed, the manual switch for the cooling fan, which is not required for that setup. You can use the variable speed controller by itself just to turn on and off based on the temperature that you select, but you can run the wiring for the internal switch to, it's a three-way switch. So in neutral position, the fan turns on and off based on the temperature you set. Turn it on and it overrides to 100% full fan off. The example they give is you might want to turn it off if you're driving through water, which in a PT Cruiser is probably pretty rare, but you know, if you're in a vehicle where you're doing like mud bogging or water sports, you can turn the fan totally off so it's not running. So what did I do? So I believe I captured the video for bringing the wires in through the firewall, running them across, as I've done for a number of things, over into the bay where the switches are. Normally you'd see things like rear defrost, rear wiper and washer. This is where I already installed the cooling fan switch for the cooling fans that I installed on the front of the radiator for the transmission and oil, and the additional 9-inch fan that's blowing through the radiator and condenser to try and help cool that. But what I did was, on the little switchboard here, this is the switch I installed for the variable speed fan, and it's all wired up. But to get that slot, I did pop out the track on and off switch, which I rarely, and probably safe to say never, will use. So I'm just going to tuck that back inside the dash here when I reassemble everything, and I'll be very happy just with my 2 fan control switches right here. So the wiring, the way I ran things, essentially you'd have to run 5 wires, maybe 6, depending on how you do it. Okay, so for this can be ignition switched or constant power. I happen to have it wired into the constant power for this switch, which means I can turn it on and off even when the car is turned off or the ignition is not on. I ran the green and orange wire to go back to the variable speed controller as the on off. So when I turn the switch up or down, these are the 2 that send that signal for on and off. There's the ground, of course, and then there's the what else? These additional 2 wires, and this is also optional, you don't have to do this. They're purple and yellow, which you will also find purple and yellow on the variable speed controller. Those are the 2 big wires that go to the fan itself, providing ground and power. I just tapped into those out on the variable speed controller itself and ran them to, here's the little connector I put on, to this little LED light. And the idea being, when the fan comes on, whether it's automatically based on temperature or I turn it on manually, or if the air conditioning unit turns it on, this light will come on with the fan itself. I tried wiring that little LED in using, like the on-off here, or the ground or whatnot, or the ignition. Basically what I'm saying is I tried wiring this LED in to something interior wise on that switch, and it didn't work for me. The light would just come on all the time, probably because it was just getting constant power, constant ground. So I just said, all right, I want to actually know when that fan is spinning for real. So the best way to do that is to wire it into the same connectors that go to the fan itself, and I'll show you what I mean. So on the variable speed controller, remember it's the purple and the yellow, so those are the same colors coming out of the variable speed controller. You've got the purple, which is ground, so that goes to this fat wire, which is going to be the ground on the fan itself, and the purple one that goes back into the dash to that LED light. Same thing with the yellow. You can see the fat yellow coming off of the variable speed controller goes to the blue wire, which is going to go down positive to the fan, and the purple wire back into that LED. So whenever the fan turns on out here for any reason, the LED will come on. It's a nice little notification. I also wanted to mention the air conditioning wire, the wire that will activate the fan whenever you turn on the air conditioning. What I've done is, this is the high-speed radiator fan relay spot in the PDC. Okay, you can see there, and I am plugged into pin or port or 85. Okay, because that is the negative, also signal wire pin that the PCM switches on and off, or sends a signal to or not, when the high-speed radiator fan is supposed to turn on, including when the AC is turned on. So I put the relay that was in that slot in the spare slot now, but just so you can see, pin 85, that one right there on the right side, that's what would normally go into that slot. And the way this variable speed fan controller works is you can either select a positive or a negative signal for the AC to tell the fan to turn on. And because on the PT Cruiser it's a negative signal, that's what this one is. Goes to its number 7 or port 7 on the speed controller. That's that green one coming up here over to that pin 85. I was skeptical if this was going to work, but I wired it like this on my Durango and it worked. It works great. So I'm assuming it's going to do the same on the PT, and I'll soon be able to test that. Something else I didn't capture on video was actually dropping the fan assembly down in. Got it all removing, but dropped it in just like it would a stock fan. But as I put on the video, what I've done is installed the Flex-A-Lite Black Magic fan into the stock fan housing assembly because it fits. The one I was hopeful, the Black Magic assembly, which is the same size, like you can hold it up to the stock PT Cruiser fan housing assembly, and they're essentially the same exact size. So I was hopeful that this assembly with the Flex-A-Lite Black Magic fan would just drop right in, but it does not. It's too fat in areas. It just doesn't fit in properly. So I had, as you saw, I had to remove that fan, put it into an extra turbo model fan assembly that I had, swap the fan in there. I ended up having to put it in backwards because of how it's mounted. So that just means I have to reverse the flow of the fan, which you do by switching the wires. So down here, let's see, this big mess of wires here, that'll cut down and actually be the positive and negative coming from the variable speed fan controller, but I have to swap them. Blue normally positive, black normally ground. Because I had to swap the fan around, here's the two that go up to the fan, also blue and black. I got to reverse them, so that's what I'll do. Black to blue and blue to black. But then it'll run in reverse and draw the air through the front. So what are we doing next? We have to add in the temp sensor that'll activate the variable speed fan control. And here's my first temp sensor. This one just sends the temp to the gauge inside the car. Now, there's a number of ways you can add in the temp sensor for the variable speed fan control. You can get a temp sensor that you actually just stick through the fins of the radiator and it sends the signal. That way it's one of those, I'm not sure what you call it, poke it through. I think I have one here from the kit. This is the Flex-A-Lite variable speed fan control kit. Here's one of those little guys, and you can just poke that into the radiator. It senses the temperature. You could do that. Or you could use this adapter, which is from Flex-A-Lite. What is cool about this is that it has two ports, so you can have two temp sensors. So you could have one going to your gauge, like I have, and one that goes to the variable speed fan controller. I used this on my Durango, worked great. Part of the reason is because it was the right size for the radiator hose. This is a 38 millimeter. That's the smallest size you can get, and that was the right size for the Durango. The PT Cruiser though has a smaller hose, and it's upside down, but you can see the size of, if I can get it to focus, the size I have for this temp sensor adapter thing is 34 millimeter. Okay, so you could try and get your radiator hose to stretch over this, or get some sort of adapter that goes from one size to the other, because I doubt I'm going to be able to fit that inside the PT Cruiser hose. It's just too fat. So I looked into a couple other options, and here's what we got. You can get your adapters that have two threaded ports ready for temp sensors or whatever you need. So that would be wonderful if both temp sensors were 1/8 NPT thread, which is what the Autometer temp sensor is that goes to the gauge inside my car. The Flex-A-Lite variable speed fan controller temp sensor is not 1/8 NPT thread. It is 1/4. It is larger. So, and you can see that there's the thread size of the temp sensor from Flex-A-Lite, and you can see the difference there. So it's smaller. So then the option is, all right, I could drill out one of these bigger and tap it so it's the 1/4, the proper thread, 1/4, 18 NPT, I think is what it is. But as you can see, that would be pretty tight. I would need a drill press, which I don't have at the moment, to really make it exact, and there's no space on the outside edges to really drill any closer. So you would have to do it just right, you know, making the hole bigger on the inside, which is doable. especially if you have a drill press. So that's one way to do it. So a couple problems is A, I don't have a drill press, and B, remember we need a 34 millimeter adapter thing here to fit with the PT Cruiser radiator hose. All they had was 38, like you see here, and then 32. There's not a 36, and they were all out of their 34. So I could try and do it with the 32, but that's kind of small. So then we have the next option, which is the one I'm going to go with. I had another, sorry, it got scratched up when it was in my vice grip, but I do have another 34 with a single temp sensor one, which was easy enough for me to drill out just with a drill in a vice, in a vice grip, or not a vice grip, but a vice, table vice. So I squeezed this in here, drilled it out, and tapped it for the 1/4 NPT. So that can work, and this will be the one that goes to the variable speed fan controller. So that's what I'm going to do, is essentially have two of these in my radiator, upper radiator hose. The one that's there to send the signal to the auto meter gauge, and what I'm going to do right now is remove the upper intake manifold so that I can get to the radiator, upper radiator hose, and I'm going to cut out another section to put in that Flex-A-Lite temp sensor that'll go over to the variable speed fan controller. So I'll have two, because I'm really happy with this one. I don't want to mess with it. It works great. So I'd rather leave that alone anyway. Plus I already have the hose all made the right length and everything to go to the radiator from that one. So just gotta make a new cutout for the new temp sensor. That's the last thing I got to do to install this new fan, and then I can put it all back together and start testing. Triggering the AC, or having the AC trigger the Blackmagic fan to turn on has been trickier than I originally assumed. I had a lot of success just doing pin 85 on the high-speed radiator fan relay in the power distribution center on my Durango. That did not work on the PT Cruiser. And I'm gonna give credit where credit is due to Martin Built, another YouTube channel, where he did this same fan swap on his Jeep Grand Cherokee. And it seems that the PT Cruiser is wired a little more similarly to the Jeep Grand Cherokee than it is the Durango. And I think part of that is because the Durango had the clutch fan, the viscous fluid clutch fan, which just spins on its own, is not hydraulically or electronically controlled. And I think that made things a little simpler. That's just a rough guess. But here's what I've found is that on the PT Cruiser, long story short, you got to have both those low and high speed radiator fan relays installed for the fan to turn on properly, especially with air conditioning. Not only that, after a lot of troubleshooting, what I found is that the air conditioning was not turning on, probably because the compressor wasn't cycling properly or whatnot, when the factory fan was disconnected, which is what I had done. Is I just left the here, I'll just show you, factory fan connector left just like this. Here I have the new connector all made for the Blackmagic fan, which is installed. Okay, and that goes to the variable speed fan controller, the loom that I made. That goes back up. But this is the issue here. Disconnecting the fan was making the AC not turn on, and not only that, it was preventing, therefore, this fan from turning on. But that tells me that somehow the PCM is seeing the stock fan when it's connected, and therefore it knows, okay, it's safe to turn on air conditioning and not worry about the car overheating. Much like what Martin built, described in his video, there's got to be a relay, or at least that's my guess at this point. I was encouraged when I looked at, this is the stock, another stock fan for the Turbo PT. There's the relay. From the looks of this wiring, even though we see a red and a black going to the relay, really the actual ground wire for this loom and for the fan is separate. The red and the black go to actually the red and the blue. And on the PT, the red and the blue, which come from the power distribution center and the low and high speed radiator fan relays, those are each the power or the positive for each relay. In this case, the red is, high or low, and then the blue is the other. And the stock wiring colors are typically yellow and green, correlate to where the red and the blue go. So you would see on the factory connector yellow and green there instead of red and blue. And going from what Martin described in his video, and what I think is happening is this relay is missing. So the PCM thinks the fan is not there, therefore the air conditioning will not turn on, even though I've got everything else set up right, and I've ran the Flex-A-Lite AC controller. I tried on the ground activating terminal, which is pin 7, going to the high-speed radiator fan relay pin 85 port. Did not work. Tried it on the positive one, the pin 87, that gets the positive signal that then gets sent down the yellow wire, which becomes one of these, the red or the blue. Also did not work when the stock fan was disconnected. That's when I started cluing in that I probably needed to do what Martin did, is that the Flex-A-Lite fan started working when I left the stock fan plugged in. Like it would turn on with the AC as I'm trying to get it to do when this fan was still connected. So there's something about having this fan connected that makes the PCM say, I'm safe to turn on air conditioning and make everything work. And I think that's it, the relay. So from the same stock radiator fan that I put the Flex-A-Lite Black Magic fan into, the one that's currently in the PT, I still had the wiring from it. So that's what I'm working on here. So there's the stock one. You can see they're using different colors on each one. This one has black, red, and green versus black, red, and blue on that one. But in any case, there was that resistor. The stock one was broken, so I got the same one mentioned again in the Martin built video. It's just a 10 ohm, 100 watt resistor. So just like this one that had the red and the blue, which turns into red and black that go into the resistor, this one has the green and the red, which is interesting because it's one of these is the low speed low speed radiator fan positive signal that comes from the relay in the power distribution center. The other one's for the high speed, and they just put a relay between them. I don't understand the logistics of all that, but that's what I'm trying to simulate. so that the PCM now thinks that the stock fan setup is still plugged in. The ground wire, which is also a part of the setup, I'm just gonna use some self-tapping screws, mount this somewhere underneath on the PT, and ground this right there with the screw going through it into the frame or wherever it is I ground it. And then cross fingers, when I plug this in, the Flex-A-Lite Blackmagic fan will work as I'm wanting it to when the air conditioning is turned on. So let me finish getting this all set up, and then we'll see if it works. Here we are. I've got the resistor installed, and here it is. So it's right underneath the radiator. It's not pretty, but there's that with the ground wire that goes over to the connector there. Have it zip tied and then plugged into the stock connector there. So now it's time to see if it works. It is working like it should. So we got the resistor installed, as you saw. The variable speed fan controller for the Flex-A-Lite system, pin 8. I suppose I could use either the negative or the positive, but in this setup I use the positive, which is pin 8 on the variable speed controller. That goes to pin 87 on the high speed radiator fan relay, because that is what gets the positive signal that goes down to the radiator fan motor and turns it on. So I'm using the positive signal to trigger the Flex-A-Lite fan, which is coming on when I turn on air conditioning. I'll show you that real quick. So the car is running. You can watch this LED, although the light on the camera might not let you see it very well, but I'm going to turn the AC, and you can kind of see there that LED came on. That is because the Flex-A-Lite fan also actually came on. It's down there running. And once again, there's that relay we had to install. That's comes on the stock fans. They have that built-in relay, or sorry, not relay, resistor. So I guess the PCM needs that, or else you get no AC, and your fan does not work as it should. So there's a stock connector, which I used the harness from the extra stock fan I had. That's how I did all this. And then up there, that's the Flex-A-Lite fan wiring. It does feel warm. It's pretty toasty. Let's turn the AC off. And it takes a while. It runs for a bit before it shuts off, which is what it does stock fan as well. But we'll see the blue light go out eventually as the fan also turns off. And soon, because it looks like it's right getting to 180 degrees, it should turn back on just for standard cooling. I think it kicks on at about 190 degrees when it starts cooling due to heat. Well, we'll see. Okay, there it goes. Just turned off. I don't know if you can tell. There we go. And I have AC is turned off now, but it should come back on pretty soon based on the temperature. So I have it at 180 degrees on the stock temp gauge. You can see it's a little below the midpoint, which what I've seen on every PT I've ever driven or owned, when you get to the middle bar there, that's usually where it sits for a happy temp. Okay, so with how I've got the Flex-A-Lite fan set, there it goes, just came on. So you can see it came on a little sooner than the stock fan would have, because that temp gauge is not to the center. Temperature is about, whatever that is, 185, 190, which is where I want it to be, because this engine runs a little warmer. When I was using AC before, it would start to overheat, and the stock temp gauge would start going above the midpoint, indicating I was headed towards overheating. So this is doing what it should. And I still have the extra cooling fans that I mounted on the front as well, and the fan just turned itself off, so it's keeping it within range. So it's turning on and off right around that 185 point. That's just exactly how I want it to work. And just to one more test again, I'll turn on the AC. There it turns on the fan. So that is doing what it should. Now I could also use the manual switch because I got that installed. That turned it off. Yep, LED is going out. Turn it on. Yep, I can hear it going. And that's a sure sign. All right, I think we have a fully functioning Flex-A-Lite fan, controller, keeping the PT cooler than the stock. test. 3, 2, 1. Flex-A-Lite fan is coming on when it should. Temperature seems to be right around 190 to 200. Probably not bad given the accelerations I'm doing. Time, let's just keep an eye on boost. With 1,000 miles after the motor being rebuilt, I figured it'd be a good idea to give the head a once over and see how it was doing, if there was any issues. I'm really glad I did because, and I think this most definitely plays into part of the reason why I have probably been having overheating issues. When I pulled the head off, first I noticed that the timing was one tooth off on the cam gear. The exhaust or the rearmost camshaft, the exhaust cam, was one tooth retarded. That means that it was, no, I may totally get it wrong, but it was, I guess that would be opening later. So it was the bang inside the piston was happening relatively sooner, or the exhaust valve was opening too late. So could be causing more heat in the motor for sure. Not to mention the timing itself, because of that extra tooth, could have been causing problems. Especially because the camshafts I'm using are the Brian Crower Stage 2 cams, which already have a more intense, not only lobe on or angle, I should say, on the lobes of the cam, but they change the degrees of timing as well slightly. Even being one tooth off on that cam gear may have been enough to cause some more severe issues, and I'm going to show you that it very well may have. So, quick note, the PT Cruiser, or that 2.4 liter 4-cylinder motor, after doing some calculating and figuring and looking at it, the cam gears have, the stock cam gears have 42 teeth total all the way around. So when you calculate that, it's basically 8 degrees of timing per tooth. So in addition to whatever the Brian Crower camshafts had done with timing, I was essentially adding or subtracting another 8 degrees of timing. So that's pretty extreme, and it could have caused some problems. So what did I find? I pulled off the head, and when I looked at the bottom side, I immediately noticed that there was a problem with the valves, especially on piston 1. And let me show you. We had some severe bending going on the valves. Really serious problem. And even if you can see on the bottom side, there was on this one it was only slight, but it was impacting the piston. There's a little mark of it right there, just slightly. It was impacting the piston. Fortunately, I checked out the piston. You can see the angle there, and the pistons are okay. But this was not even one of the more extreme ones that was bent. On piston 1, it was really bad. That explained why I've been hearing noises, and you might be thinking, well, duh, that's really bad, and you know, if you had valves impacting the piston, should have been pretty obvious. Well, yeah, it should have been, but remember, I had just rebuilt and reinstalled this whole motor, and it was honestly hard to tell exactly if what I was hearing was a pinging just because of a timing issue, which, you know, I even thought maybe a tune had to happen for the motor because of the camshafts and everything else, and the timing was just a little bit off that way. So sometimes it sounded like the pinging that comes from pre-ignition of a timing issue. But then I also noticed that I could rev it up to about around 2,000 or 2,500 RPM, a different noise would happen, and I'm pretty sure at this point it was that the valves and the piston coming into contact, because it didn't quite sound like a ping, it sounded like something different. So, and driving it, as I would do higher acceleration, more RPMs, that noise would get a lot more prevalent. Turns out I'm really glad I took the head off and discovered this. When I took it to the machine shop, which I finally got it back from, it took about 2 months I got the head back, and they actually replaced the valve guides, and it turns out one of them might have been slipping, or he said he didn't like the way it, I think he was saying it was potentially even moving inside the cylinder head, which of course the valve guides are supposed to be rock solid and not move. And there's the possibility, I didn't get a whole lot of explanation from the machine shop, but that the valve guides, the original ones, where this set of valves were in, they may not have been drilled out properly for these valves. These are the oversized valves you can get from modern performance. It could be that, you know, especially under higher RPM and more driving, if these were rubbing too much inside those valve guides, they could have been getting stuck. They could have been floating at super high RPMs, depending on what was going on. But definitely if they were starting to get stuck with heat and friction, then they might have potentially been pushed down and come in contact with the piston. So this is a lot of speculation in theory. I don't know for sure, and the machine shop couldn't tell me without a doubt what exactly happened. But all in all, that's to say, it was off a degree or off a tooth on one of the cam gears, which is an extra 8 degrees of timing, in addition to the stage 2 Brian Crower camshafts, which have their own adjustments and timing. And there was potentially issues with the valve guides or the valves getting sticky. So that had to be dealt with at the machine shop, and that's where I'm at now, is reinstalling everything. I'm still going to come up with an alternative fan solution. I have a feeling that after this, I sure hope so, I'm crossing my fingers, that this is going to solve the core issue of overheating. I think it was because of that head and what was going on in there. But I'm going to be using a different type of coolant. Instead of just the standard antifreeze, I'm going to be using this super cool fortified with water wetter stuff from Redline. So I do a whole setup of that. I haven't tried that before. I will still be using 2 fans in the front, but instead of those little, I think there's 4-inch or 6-inch fans, the 2 ones that I had prior, I'm stepping up to 11-inch fans that push a whole lot more air. They're about 2,500 CFM each, and that's in addition to the normal fan that goes behind the radiator. As you've seen, I upgraded that to the Blackmagic fan, which also has a higher CFM, and I'll be controlling the 2 that are in the front, the 11-inch fans, manually. So one is going to be just right in front of the AC condenser, which I should only ever need in hot weather, using AC, or if things get oddly too hot, which, again, crossing my fingers, I think with this, repairing this head and with the Blackmagic fan doing its thing. Flex-A-Lite, that's the brand, Flex-A-Lite. Shouldn't be an issue, but I will have the option with a switch, the same switch that I installed and showed, to turn on those front fans. Now, I'm also keeping one of the 6-inch fans. What I'm going to do is have the 6-inch fan on the 2 tiny radiators that I used to have in front of the main radiator. Those are going to be inside the driver's side fender well, and with the 1 fan cooling those, then I'm going to extend the line and have another cooler. I'm pretty paranoid about being the engine not overheating now. And I wanted to show a couple other things. I got these upgrades also from Modern Performance, but you can get the little rocker arms you can also get from Rock Auto, or really anywhere that sells this part. What I'm talking about now, well, let me show you the 2 things that I got as an additional upgrade for performance and better vacuum and better oiling for this setup. Okay, so first the rocker arms here. These, which you can order as a set from Modern Performance, you can get them off Rock Auto or anywhere that you can find this part. These rocker arms are from a 2.7 liter V6 Dodge motor. But the 2.7 liter V6 you can find in a number of different vehicles. But the rocker arms here, the reason those are, trying to get it to focus, sorry if it's not focused, but they're special because they have the little oiling hole, the hole that the oil squirts through as it rotates and the oil is coming up through the lifter and into the rocker arm and squirting back onto the roller to help lubricate that and the camshaft lobe as it spins on it. You can see that little hole right there is pointing towards the roller. That is particular to the 2.7 liter V6 motor. The stock ones for the PT, they point straight up. These are the 2.7 liter. So again, the idea is better oiling because that oil is getting squirted right back onto the roller of the rocker arm and help lubricating the camshaft. The other thing I got from Modern Performance, and I don't know if you can get these separately or straight from Rhodes, but are the lifters. These, you're not going to be able to see it, but these have been customized. I don't know if they ground them out wider or whatnot, but basically there's more oil flow. They squirt more oil because Rhodes has gone in and modified the original lifters to do that. So more oil squirting through those lifters. And if you go to Modern Performance and look at these where I got them, what they claim, and they have a video that shows it, is that this also improves your vacuum pressure. I do want that extra vacuum pressure. That's great, right? Other thing that I suspect is going to improve with fixing this head and those valves that were bent so horribly is vacuum pressure, because obviously that's getting lost with bent valves. And I had a whole separate video for replacing the power brake booster and the master cylinder. I did both. I don't regret doing that because, you know, it's never been done on this vehicle, and with the changes I've done to it, I don't mind having those being replaced and you know, new and reliable. But even after I did those, I noticed since the motor swap, the braking pressure, like when I push on the pedal, has been erratic. Sometimes seems like it's fine. Other times, particularly when I'm at lower idle, like coming to a full stop, it's like I have to push a lot harder because I'm not getting the brake. It's like the brake booster isn't doing anything. It almost feels like I have manual brakes sometimes. And now, you know, after I saw the valves being totally bent and definitely leaking a lot of pressure, I hope and I think that my braking will improve as well with repairing the head and fixing those valves. Okay, back to the rocker arms. Remember the 2.7 liter Dodge motor V6. The oil hole points back at the roller of the rocker. The stock PT Cruiser or Neon or any vehicle using the 2.4 liter rocker arm looks like this. I hope this focuses. Looks like this one. Okay, that's kind of in focus. You can see the hole for the oil that it comes through points straight up. It is not pointing back at the roller right there, right? It's just pointing up. I mean, oil is still gonna squirt all around in there, whatever direction they're pointed, but the idea is with the hole pointed right at the roller, you're gonna get better lubrication, better for your camshaft. This is an addendum to some videos I've posted prior of installing the timing belt on the PT. And I'm doing this because I'm finding it easier to do now using pretty much the service manual recommended way of installation. All right, the first thing you should do is lining up the crank sprocket, the arrow on the oil pump, this one back here, and the arrow on the crank sprocket. Those should be directly lined up. So when you're about to do your timing belt, first thing you do is line up the crankshaft sprocket. And the way you do that is there's the arrow right there on the sprocket and the arrow back here on the oil pump. And you got to line those up. And this can be deceiving, but you can see how the arrow on the sprocket is more lined up with the trailing edge, the back edge of this particular tooth on the sprocket. And what you should try and do is make that line up with the top one as well. So let me spin this around again. Okay. About right there, you can see they both kind of point at the back, but I'm going to do it one more time. I went a little too far. You always want to go clockwise, okay? That's the direction the motor spins. So I'm going to go that. Okay, I'm going to start about right there and see how we can do with that, getting the cam gears to line up. Another word of advice when you're doing the timing belt, for the sake of being able to rotate the motor much more easily, which really helps, take out the spark plugs. Okay, mine are all removed so that there's no vacuum and pressure that'll build up, and that really helps you spin the motor more easily, which is very helpful in when you have to do that to test that the belt's on properly and to just get everything to line up. In my previous videos, I've talked about, I'm going to turn the camera around so you can see the timing belt. In previous videos, I've used a method of essentially taking off one of the cam gears to run that belt around and then get it in the right place, and then you put the cam gear back on the camshaft. It's not the easiest of procedures, but I recommended that because I had more success. It was easier, at least at the time when I did it, to do it that way and get the belt over the tensioner pulley. What I've found essentially is that within the last 1 or 2 years, the tensioner pulleys, I swear they have got more give, more loosening abilities to them, which gives you a better ability to get the belt over them. What was so difficult in the past was that if you tried to do the service manual process where you first you put the belt on the crankshaft gear sprocket, then you have it travel up to the water pump, wrap it around the idler pulley, wrap it around the intake cam gear, the front, and then you rotate the exhaust cam gear to where it's 1/2 a tooth. This is needs to be rotated a bit, but you do it where the 2 lines right here that I have marked with white out, the exhaust one is slightly lower. It's about 1/2 a tooth lower right there. But then you continue to run the belt around and wrap it around the tensioner pulley. And then what the deal is when you get it fully on there and you tighten it, it's supposed to pull and spin the exhaust cam gear into the right place. Okay, that's the factory way of doing it. The way I was doing it was more complicated, but I did it because I would have better results, and it was easier to get the cam gear back onto the camshaft versus trying to wrap the belt around that tensioner pulley. But like I say, that seems to have changed. So now I'm doing a hybrid of my 2 methods where I essentially do the service manual process of installing the belt. Okay, so I'm going to wrap it totally around. You can see I have the ratchet on there. I'm going to rotate the exhaust one clockwise just a hair to get that mark on the cam gear a little lower below the intake one. Okay, it should be about from where it is now 1/2 a tooth or so lower. And what the service manual doesn't say to do is this, and this is a lifesaver, and I'd say definitely have a vice grip that you can put on the camshaft. Notice I am not on a lobe. Okay, this is on one of these rough surfaces of the camshaft. I'm grabbing there. It's resting against the head, the cylinder head, preventing that from rotating because the pressure of the springs and the lobes wants to spin this camshaft out of place, right? And I want it to stay exactly where it is so that my mark is where it needs to be, you know, so that you can line them up. That's why you need that vice grip or something else like it. I've seen some people will use a metal rod or a screwdriver down in this hole of the camshaft. Both cams have that, and it lets you kind of maneuver it like that. What I found is if you can get it into place, you know, even by using that hole right there, then you get the vice grip on it, and, you know, and block so it won't spin once you've got it in the right place. Now I can line up the exhaust one and get the belt on there properly. So I'm going to do that now. See, I just spun it just that little bit, and that was enough to let me get the belt on. I don't know if you can't really see it, but the exhaust mark there, it's a little more in focus. You can see how I'm trying to have it just a half mark below the intake, okay? Right around there. And then the belt will sit on, and basically once the tension goes onto the belt, it should make those marks line up. All right, so let me get that there. Okay. And now, okay. So I just got it over the tensioner pulley. It's just sitting on it right there. I wanted you to see that. So I was able to, just by hand, pull that thing over the tensioner pulley. That has been the extreme pain in the ass in the past because that tensioner pulley wouldn't rotate enough to loosen the tension on the belt. But now, recently, it seems like they do. So my whole process of using the cam gear as your take that on and off to get the belt on, while it will work, maybe isn't necessary anymore. But again, vice grip definitely necessary, or very helpful. Highly recommend that. Okay, so now once you've ran the belt around the crank sprocket, the water pump, the idler pulley, the intake cam gear, you ran it around the exhaust cam gear and rotated it so you got your two marks, with the exhaust one just about, well, now it's almost lined up, but that's because I'm kind of already got it pulled on. But we still have to test it a bit more. So there we go. I now have the belt on the tensioner. I need to apply tension, tighten this tensioner pulley down, and then rotate the motor at least 2 full rotations of the crank sprocket, because that'll do 1 rotation of the cam gears, to 2 of the crank sprocket to 1 of the cam gears. And I'm going to actually do it a number of times, checking up and down, back and forth, because I want to make absolutely sure that these marks stay lined up after the engine rotates. So I need to first apply tension to the belt. To do that, we'll use a 6mm Allen wrench. It goes right into that tensioner pulley hole. That is a 6mm. Okay. Now, as you can see, as you rotate that is what puts the tension on the belt. Okay. And there's a way you know exactly where it's supposed to sit, at least according to the service manual. All right. So you can see this here is our tensioner pulley, and then you'll see that kind of weird looking, it's a tang and then a spring with see that mechanism that's wiggling back and forth as I rotate the tensioner pulley. And what you're supposed to do is rotate it until, wait a minute, I'm going backwards. There we go. Okay. So first of all, I had to kind of go back and forth a little bit with our Allen wrench here. Sorry, this is a little tricky holding the camera and doing this. Okay. All right, you can see as you rotate it, that tang and the spring are moving, right? And what's also happening is the belt is getting tension. And you know you're at the right spot for tension. First of all, notice how, see when you're rotating how the tensioner is moving towards that way. It's applying tension on the belt, right? But you know when you're in the exact right spot, when the tang is right there. And what that's supposed to be is that little spring, that little pokey out spring guy, this one here in the back, that is supposed to end up in the tolerance window, which is what is on the tang that's moving back and forth. That little spot right there, that is your tolerance window. And you want that spring, that straight thing that's going down in there and poking up and down. It needs to be within the tolerance window, okay? So really it could be like anywhere from here to about there is the tolerance window. And when you're within the tolerance window, that should be applying the appropriate amount of tension on the belt, Okay, you can kind of see that moving and applying tension on the belt. So let's get that within the window. Let's make sure that's right. Okay, that should be about right. It's within the window. And that's a good amount of tension on the belt as I'm feeling around. So I'm gonna check out my Allen wrench, my tensioner. Tighten this guy down, making sure that it stays within that tolerance window. Ah, see, it's starting to want to move. I might need it. Yep. Need to keep the Allen wrench in there and hold it. So you got to do a real tricky two-handed sort of hold. Like sometimes I have to kind of go back and forth, and then it goes a little bit better. I don't know if that tang is just getting tired. I don't seem to want to. Tighten it up. Just going to tighten it down just a little bit more to apply some pressure on that mechanism that's spinning. I think it's maybe a little too sloppy right now. There we go. Try that. Now technically, that is not within the tolerance window, but I'm watching the belt as well, and it's getting the tension it needs. Well, I mean, I guess if I'm looking at the top of that spring back there, that's definitely within the window. Let me make sure in the service manual that that's okay, or if I'm supposed to be looking at the base. Yeah, that should be totally fine. Because according to the service manual, you kind of look at the top of the spring there as you're doing it. Really, you look at the whole length of the spring that's sticking up. It needs to be so, like that's good. Okay, and if I check the belt, yep, that is nice and tight. So now I'm gonna tighten down our tensioner. Oh, that's right, keep pulling out the Allen wrench. Don't do that because it's going to spin. So you got to hold it. Alright, so make sure the tang doesn't move. By the way, I'm using my phone to do this, and that's great because I can see it on the screen, because it's really hard to see down in there while you're doing this. Wanted to share, this was my first attempt, and I noticed after I got the belt on and I looked down at the crankshaft sprocket, it had moved a bit, and so this happened. So I've rotated the motor a number of times, and as you can see, the marks are not lined up. The exhaust one needs to be down more. So what I can do, I have my crankshaft sprocket is lined up. You can see the two arrows. Okay, they're good. My intake sprocket is probably in a good spot, so I'm gonna clamp it in place so it won't rotate. Okay, now what I got to do is loosen the tensioner pulley so that I got some slack, and then put my socket on the exhaust cam gear and spin that forward about one tooth. Slack. So now okay. They're about a half tooth off from one another. Let's go ahead and do up the tensioner. So just to wrap it up, after having to do it multiple times, we can see, I think I got it. So here's our two lines that are, there's the one, my fingernail's in it, and there's the other right there. They're almost straight across, very, very close. And then if we look at the crank sprocket, we have that lined up as well. And then you can see how that oil pump arrow is kind of more towards the center or frontish even. on that tooth of the sprocket. So I'm going to just tap the this just a hair, so that both the arrows are kind of more towards the back. Got to be careful because it'll pop forward on a cam lobe and totally go past. Okay, yeah, kind of like that. So it's just a hair past. I'm gonna do what you shouldn't do and go backwards just a hair. All right, that's good enough. And I did that because I want to see how the lines are. Let's see how it's below now, about a half a tooth. So I just want to test again. So I'm gonna crank it around another 2 full rotations, because that'll be 1 full rotation of the cam gears. See if I can get it where you can see there's the marks. So that was 1 rotation. All right, coming up on 2. Oop. Oof, that might be right there. Right there. That's yeah. Okay, so now I got that arrow at the front side of that tooth. Let's see how that lines up. Okay, so now they're almost straight across. I think we're good. I think we're good. That was using the hybrid process. Installing the belt, basically how it says to do it in the service manual. And again, unless I'm just straight up crazy or didn't know what the hell I was doing in the past, I think the newer tensioner pulleys, like within the past few years, just give you enough more wiggle room to where you can pop that belt over them better than it used to be in the past. Because I'm telling you, you'd be sitting there trying to get that belt over the tensioner pulley, just breaking your knuckles doing it. And then just remember vice grips to hold the camshaft not on a lobe. Makes a huge difference. Another quick helpful tip when you're trying to install the timing belt and make sure that everything's lined up right, you want to have the motor. You can see I have a jack blocks under the oil pan. You want to have it at just the right height, jacked up and down, so that you can visually inspect the arrows on the crank sprocket, the oil pump, and turn the crank, with some sort of wrench on that bolt, but also be able to visually inspect and access the cam gears. Like so. So it's slightly lowered the normal position of the motor. Coming back to it this morning, and I just wanted to rotate the motor over few more times to make sure that the cam gears are lining up properly. Right now they're almost exactly straight across. I'm going to rotate the motor around a few more times. Remember, 2 times for the crank for 1 rotation of the cam gears. And you can see how I got the arrows lining up like so. They're almost directly in front of each other. So I'm just spin it around another time, another 2 times. And also a quick reminder that removing that headlight, passenger side headlight, is a good idea because of the access you gain to everything on this side of the motor for when you're doing timing belt and a lot of other components that are over here. It's extremely helpful also for the visual aspect, so you can do things like see the cam gears while you're rotating the motor when you're trying to do the timing belt install. It's very helpful. Okay, that is twice around. So let me make sure these arrows line up. Start with that. And you can see my white marks. That's looking pretty good. Let's look at it from above. And, you know, all things considered, the angle of the engine, because, you know, you want essentially a straight line across. And I don't know if I can get it much better than that. If I moved it a tooth, that would be pretty far off. If you wanted to get like a straight edge to compare, you could. Keep in mind you have the notches in the cam gear on both sides. So like on the exhaust, you can see the one that I marked with white out because you can see it says up. They both need to have the writing right side up and with the arrows pointing up, and those marks should line up. But you can see you have marks on the outside here. Somebody marked this one with yellow before me. But if you wanted to really see if you're at a good horizontal straight across lined up way, you could do a straight edge that kind of would go across both cam gears to bring you to the outside notches as well. I don't think I need to do that. I'm pretty satisfied. I've spun the motor over now quite a few times, and I keep coming up about right there with those timing marks. And yeah, if I tried to move this up another tooth, I'm afraid it would be pretty far off, which is what I noticed when I disassembled the motor the first time. The exhaust tooth, this line was probably about up here. So that compounded with, I believe, this is my thought, is that the Brian Crowder Stage 2 camshaft with its lobe profiles and timing adjustment added in with the additional timing adjustment that would have occurred by retarding the exhaust cam like that, could have played a factor into what happened with the bent valves and the whole cascading events that occurred after that. If you watched some of my earlier videos, I had the 2 smaller fans in the front set up to cool both the oil and the transmission fluid. In my, what I think is the final version of the fan and cooler setup that I've got, those smaller coolers are now we have those smaller coolers over here, they're going to be behind the fender and the bumper. They fit. I've had it like this already. You can see the oil and transmission lines coming here as they run. There's the filter that's going back to the transmission, and then the oil lines follow the power steering lines back there and over to the oil filter. Okay, so I think I was fighting the cylinder head, bending the valves, and having a lot of vacuum issues and overheating as a result of that, and the retarded timing because I ended up, whether it jumped a tooth or for some reason I was one tooth retarded on the exhaust cam. So a lot of heat issues, which is part of why I've been paranoid, and this, you know, might look insane to some. But here's what I ended up with, and in case you ever want to upgrade the cooling or add fans or whatever it is, here's what I've done. Give you some ideas, maybe think about it. As you can see, I've got these two. They're 11-inch. They happen to be from American Volt. They are about 2,500 CFM each, so a lot of cooling. This one is just right up against the AC condenser. That should hopefully help make the air cooler, because I'll be keeping the condenser cool in hot weather. And then behind this fan, I also have an added 23 row transmission cooler. And of course, here's all the wiring for it. You can see here, this is the straight out of the transmission. I go into this front cooler where it's going to get more cooling. Then the output there, the output of the cooler, that comes over to what is the intercooler on the side, this tiny little radiator. It goes into the top connection there. Out of the bottom, it just goes to the filter and then back to the transmission. And then I have this second cooler here for the oil, because I just wanted more than just the stock with everything I've upgraded on the motor. So that's where it all is. Right now they are manually controlled. I have the option down the road to put on a temp sensor, an additional one, or wiring it in so that this fan, the one that's in front of the transmission cooler, can be automatically turned on. There's the stock fan turning on. This one can be automatically turned on based on the transmission coolant temperature. And the sensor, the trigger that I got, would turn it on at 200 degrees and off at 185. I have the stock fan set to turn on at right around 185 to 190 degrees. So that's why that's turning it on. And you can see here, you know, while it's running, I have kind of a noisy, the valves seem kind of noisy to me. Valves, or maybe it's just the lifters and the rocker arms. Not sure, but I'm crossing my fingers that it's not a serious issue. But anyway, if you hear that noise. But I wanted to mention also bleeding the coolant again. This is after having bled it the first time, taking it on a few drives before I came back and added this transmission cooler. And now I'm bleeding it again, and there were some more bubbles in there, so I'm glad I'm doing this. Recommendation to everyone: it's not a bad idea to bleed your cooling system more than one time once you refill it, because that air, you know, after you drive it, there might be air pockets, air bubbles that get freed up as the engine is moving back and forth and you're turning and starting and stopping. Free up those bubbles to where they actually will come out of the system a little better. So that's what I'm doing. I did see some extra bubbles come out of there doing this the second time, so I'm glad I'm doing that. That should help it stay cooler. Now I'm just letting it run, bleed, and checking that everything works as I reassemble the front end here. But so far it looks like it's doing a whole lot better. 5. Thank you so much for watching. It's been about a 2-year journey since I very first began this turbo motor swap into my PT Cruiser, the Green Machine. And I can say now I'm really happy with how things have gone. The experience, I've certainly learned a lot doing this. Know how I want to approach some future motor rebuilds and projects like this van. And things that I want to do. The PT is driving much better since the cylinder head rebuild, and since I did all this cooling stuff to it. Seem to have that overheating well taken care of. Some things that still are bugging me or that I'll be working on going forward are fixing little, I can tell there's little exhaust leaks on the exhaust line, not at the manifold or the catalytic, but kind of as it goes on back. If you recall, or if you watch previous videos, I welded and made this exhaust line. So I think I need to look at all the junctions of the line to make sure those are all plugged and leaking, because I can smell a little bit of exhaust when driving it, at least when it's idle and in park or when I'm sitting still. So I want to fix that. Need to finish the tuning, so that's going to probably take several more data logging and getting new tunes from my tune specialist. Lastly, even though I think the cooling issues have been taken care of, the weather has gotten colder now, and so that's a factor that is helping it stay cool. So I'll be curious once summer rolls around again and the weather gets hot to see how it does with this configuration and if it doesn't overheat. Yeah, so a little bit nervous about that. Thank you so much for watching. See you next time.